So here's Sacha Morin, and he worked on Gambit30-Forensics this summer, which is the Gambit new benchmark analysis tool. Go ahead.
Thank you, Mark. So yeah, I'm a computer science and math student here at the Université de Montréal. And I'm going to be 100% honest with you. I'm not familiar with compilers. I don't know much about compilers, but I know some stuff about building apps and crunching numbers in general. So that's why I was assigned to the Gambit4Forensics project. So benchmarking Gambit already has a history. The Gambit benchmarks have been around for quite some time. I think it was almost like 10 years ago or something. More than that. And there's already, you can go online and see E. Craven's work to benchmark different scheme systems. He's done some great work. But we needed something that was a little bit more personalized to Gambit and that would allow us to get some real-time feedback when we were adding stuff to the source code. So every time we push a revision on the repo or commit, then we would have a unit at the university here that would run the benchmarks and give us some numbers. And that's the first part of the project. So building a system that would allow for automatic benchmarking, so to speak, here at the university. And so every time you would push on the repo, you would have a run of all the benchmarks, and then they would be the results would be put in a customized JavaScript structure. And the second part of the project was building a viewer to see all those numbers. Because numbers are fine. You can look at tables; they're great. But if you're looking at this every time you push a revision, well, you need to have something that's a bit more, colorful or user friendly. And that's where I come in. So I decided to build this little app with Mark, and we decided to use a website for portability because it would be easier for everyone to use, and you wouldn't need to install many dependencies. So it's built using JavaScript and React, and it's on top of a library called Plotly that was developed here in Montreal for charts and plots and all that stuff. So as for the data itself, in an ideal world, we would have been able to benchmark this, but we decided to stick with the last 10 or 12 years. So since the first release of Gambit version 4, so we have about 10 or 12 years of Gambit data that we can explore. You need to take this data with a grain of salt because we still need to work on some releases and some versions because some of them crashed and some data, we're just missing a little bit of data, but it's still a good first shot at exploring the performance of Gambit in the last 10 or 12 years. Now I'm going to show you how it works. This is a very basic chart that you can look at. So you have simple benchmark, sum, and you can explore its performance over a few revisions. The idea of the software is that you can assign whatever variable you want on the x-axis or the z-axis or even the y-axis. So the y-axis will always be a performance measure, so you can have a look here. So we have real-time CPU time cycles, etc., etc. And how the benchmarking works is that we run the same benchmark, I think, 10 times. And then we take the mean of these 6 measures as well as the standard deviation. So that's what's available in the system. So you can simply look at the measure of your choice. And you can also change your options for the various axes. So a good example is now we simply have sum, but if you're interested in having more benchmarks, then you can add, for instance, ACK, or you can add, well, whatever. Let's add the third one, maze. And you can add as many as you want. You can have them all if you so wish. It's not really useful, but it's there. In terms of more useful features, you can also say, I'm trying to find benchmarks here. So here you can see the performance of 3 benchmarks, but you can also notice that they're on a different scale. So some benchmarks are, by definition, longer to run. So you can simply, there are some options for easy viewing. So you can just normalize by median to have a more comparable scale. And you can also aggregate all the traces to study the group together. So here this is an average of only 3 benchmarks, but you can also average all the benchmarks if you need so. Now the interesting part is that you're not stuck to the structure of this chart. So for instance, now we're studying benchmarks, but if you're interested in studying the question, is R6RS really faster than R5RS, for instance? If that's the question you're asking, that's something you can answer by using the tool. So all you need to do is remove the mean, set the z-axis to setting. Now the traces are going to be the setting. Go back to variables, and then you can add all the settings you want to analyze. So you can compare, for instance, R6RS with R5RS. You can add them all. Here we go. So this gives you an idea of how, well, we knew that, for instance, R6RS would be faster, but now you have a better sense of the factor between the various settings. That's an example of the thing you can do. Another thing, and I will only show 2 more charts. Don't worry, I could show charts for probably another 2 hours, but we're not here for this today. There's also bar charts available, so you can do something like switch. Where is it? All right, system. Okay, plot. You can add, for instance, bar chart. Again, that's not really useful, but you could put the settings on the x-axis, and then on the z-axis, the traces. You could have the benchmarks. Here you go. So you can always pivot the axis depending on your needs to get the ideal chart. So it's only choose a few benchmarks. There you go. So that's the kind of chart that you can generate in only a few clicks. The last chart that I would like to show, because I think it is quite interesting from a development perspective, is a comparison chart between your latest revision and the before last revision, the revision right before. So that would be here, right? So you can say that we're comparing here 2 commits. You can see that, well, this wasn't exactly earth-shattering. It was a pretty stable commit. The variation on the various benchmarks wasn't that big. But then you can iterate on the history and have a look at which commit had a significant improvement as compared to the one right before. You can see this one wasn't as good, etc., etc. So that's pretty useful. That's the kind of charts that you can use when you push some changes to the source code. You can have a quick look. Well, what was the impact on the performance? There's also a bunch of, I would call them quality of life features. So for instance, if you find a chart you like, you can save it and use it later. So you can save presets to come back to the same chart in a simple click. There's plenty of shortcuts, and as you probably noticed, there's also commit information, right, included in the app. So you can see the commit description. So for instance, here you can see that there was an improvement right here. You can zoom on it, have a look at what the commit was, and see if it makes sense that this commit would lead to that kind of improvement. Yeah, I think that's pretty much a good demonstration of the app. In terms of what we want to do in the future with it, well, we still need to work on the data generation part of it. There's still some work to be done there for it to run smoothly. We would also like to include potentially other systems at some point. So in order to compare Gambit with, for instance, Shay. Yeah, I think that's about it. Oh yes, so the main purpose of the tool is to help us with the Gambit development, but if the tool works well, at some point it might be available online for the whole Scheme community as well. So yeah, I think that's it for me. Any questions?
Can you compare forks of Gambit with the actual mainstream Gambit or branches, or you can only compare commits on the main branch of the?
Currently, it's only on the main branch, but that would be easily to implement because the app already supports various systems, so you would only need to consider like Gambit 2, like fork of Gambit as another system, and you could have an easy comparison. Yeah.
Thank you.
GitHub has what they call GitHub Actions. They're a sort of CI/CD pipeline. You can register for that, and you probably could run all of these for free and get this generated. And you have like a small Gambit file. Takes about 10 minutes to set up, and then you get that file generated for every PR. So you can have regression analysis. For example, you send a PR saying, "No, this, you got to change this because we regressed too much or whatever." So you can try to use
that would be
running everything locally here.
That would be definitely
It's not like
interesting.
it's secret information.
That's cool.
Any other questions? Yes.
Was the system designed in a way that it could be used for other purposes than like benchmarking? Like for my own code, can I use that to add some metrics that I want to?
Technically yes, but it was designed with Gambit in mind, but it's an independent JavaScript app, so and it runs on the data set. So if you have a data set of other
I
things,
can just add that all of the data is JSON, right? It's in JSON, or
yes, it's a JSON file. Yeah.
so in principle, if you just generate your own JSON with the data you're interested in, it
So
will work.
there's there's a format, and if I generate
Yes, so
the exact format,
I think everything sort of adjusts to the data, right?
Right.
Because the fact that the names of the benchmarks, the different systems, etc., they're all described in the JSON format.
That's right. So we have designed some kind of custom JavaScript structure, and the app reads the file and generates the options accordingly. So there are very few things that are hard coded in there. There are some exceptions, but the vast majority of the program it will strictly depend on what you put in the data structure.
Could you just show the JSON file?
The JSON file. Yes.
Just to show it very briefly.
Sure. Not sure I had it locally. Oh, so it's a GS file, yeah. Yeah, it is pretty good, pretty big.
View raw should work.
View raw should work?
Yeah, I think so.
Alright. I was about to download it.
There you go.
There you go. So you have all the fields you need to identify the data set as well as your various options. And the data is structured in a kind of recursive tree to have quicker searches, essentially. Yeah. And here's the commit information, but the data should be, here you go, data. Yeah. And we also have access to standard deviations as some kind of error measure. So here, well, it's not obvious because those benchmarks are quite stable, but you can have an idea of how stable the benchmark was. But there's still some work to be done in terms of how do we aggregate standard deviations and be sure that it's all statistically valid. So I need to have a look at that.
This display, how much of the effort is running on your laptop and how much on a server somewhere?
It's on the laptop.
Nice.
So
Nice.
when you open the
Except
page,
for downloading the file.
exactly, you only need to download the data set, and once it's downloaded, it's completely offline.
Nice work.
Is this using the JavaScript backend? I mean, Target, by any chance?
No, it's not.
Yeah, that would have been interesting.
Maybe 2.0 will use the JavaScript.
It works now, why?
Yeah.
So it's private for private use only for now?
Yeah, for now it's private use only. Well, you can actually find the tool online if you look for it, but it's not available. Yeah.
Oh, it's right there.
Yeah, it's right there. So yeah, you can find it and play with it. Yeah, for sure.
I had a question. Why did you choose some for your demo?
Why did I choose some for my demo? Because there was an interesting drop here. So that was.
Like, is it the only one that has a drop?
No, it's not the only one that has a drop. So you can see AC has a drop, and you can see that there's a bit more, that the measure is not as stable here. The benchmarks were a bit more spread out. But I chose some as well because it's stable over versions. You can see that other benchmarks can be quite erratic. So we need to figure out if it's really because of the benchmark or because of the way we're benchmarking. So there's that. So yeah. And in terms when I said you should take the data with a grain of salt, this is a good example here. Clearly this is an outlier, so we shouldn't give it too much weight. Yeah.
So all of the hash of the commits are since the, oh no, I see version 4.9.0 there. But they're still fairly recent.
Yeah, they're still fairly recent. So you can have a look here. Yeah, they're since 4.8.9 we have commits, and before that it's only releases. Any other questions?
So say that you have commit hashes and tags. Can you choose between two commits, like anywhere in the commit tree? Because right now I see that you can cycle between pairs.
Oh yeah, you can. So yeah. All right. Just give me. So you mean? So we're comparing.
But let's say that I want to provide one specific commit to compare with right now or before.
Say you want to compare. You want to compare the oldest revision we have with the newest, for instance. Yeah, that's something you can do. The app works a little bit better on a wider screen, that's why I need to go down, but you simply need to set the baseline mode to manual, and then you can compare with the first version here. So we have the first version here compared with the latest commit, and that's what you get. So you can see the distribution on the majority of benchmarks performance as improved.
So is the red one because some benchmarks are actually slow?
Yeah, some of them are slower according to our data, but others are faster. All right, thank you everyone.